Alright, so today we're going to look at polar coordinates. So I want you to take a second and see if you can answer these first 5 questions. So it says air traffic controllers monitor the space around an airport by keeping track of various airplanes, locations, and movement using a radar screen. At the center of the grid is the air traffic control tower. Okay, so the center right here would be the air traffic control tower. The radius of each of the surrounding rings increases by 5 miles. When an airplane enters the tower's airspace, it is seen on the grid by a bright point called a screen pixel. So take a second and try to answer these questions for me. Okay, so it says an airplane is 15 miles away. Okay. From the tower, show all the possible locations of the plane. Alright, so 15 miles away, so one ring is 5, so it's 5, 10, so 15. So I'm going to get that highlighter, I might be able to do that a little better. 5, 10, 15, like this. So these are going to be 15 miles away. So on that ring somewhere, we will be 15 miles away. So my radius here is going to be, so we would say R is going to be equal to 15. Okay. Alright, so because this information alone is not enough to locate the airplane, controllers also mark locations with an angle that is measured counterclockwise from due east. Okay, so due east, so counterclockwise, so very similar to my unit circle, right? Plot a point that represents the location of an airplane that is 15 miles and 120 degrees from the tower. Oh, I think I did that, didn't I? So that's 15 miles and 100, and I did that. And that first little dot right there. Okay, so this is called a polar point. So a polar point is represented by a radius. So our R is going to be 15 and at 120 degrees. Okay, so it's going to be your R and your theta value is going to be a polar point. Okay, you could also have the negative direction, the negative angle here. So other ways, so alternative names. So alternative names, and this is kind of important with polar points. So you could have 15, and then if it's negative, so it'll be what, negative 180, negative 240. Okay. You could have a negative radius. So it's kind of weird. You would call it a negative 15. And then that would be at 300. So the same location kind of down here. So it's going to be at a 300 degrees. And the other thing is that you could add 360 to that. So it would be what, 15? 15 and then what, 480? 480. Alright, hot air balloons are not allowed within 20 miles of an airport for safety reasons. If a hot air balloon is identified on the radar screen, police must be notified of its location. The police must be given rectangular north, south, east, west directions in reference to the control tower to find the possible offender on their GPS. If a hot air balloon appears on the radar screen at this point shown, what coordinates should air traffic controller give the police? Okay, so at this point here, okay, so at this point here, the balloon is hits the radar screen. Okay, all right, so let's think about this for just a second. So here is my x-axis, basically, right? So here's my x-axis, and then here would be my y-axis. And then we've got this long hypotenuse, right? Okay, so we know this is what? 30 degrees? So that's my 30-degree angle. Okay. All right, so, what is going to be this r value? Well, here, this is x, and this is my y. So what is going to be my r value? So my r value is 5, 10, 15, 20, 25, 30, 35. So my r value is going to be 35 here. Okay. So how could I find x then? So x would be what? If I wanted to find x, it would be ratio of adjacent over hypotenuse. So it would be cosine. So cosine of 30 degrees is going to be equal to x over 35. To find y, it would be your opposite, right? So it would be sine of 30 is going to be equal to y over 35. So to solve for x, we'll just take our radius and multiply it times cosine of 35. Or cosine of 30, I'm sorry. To find the y, we'll multiply radius times sine of our angle, 30. So this is going to be what? 17 point, 30.31, and then this will be 17.5. So 17.5 miles in miles. Okay. So to change polar points into rectangular points, we will use x will be your r times cosine of your theta. To find your y value, it'll be r times sine of theta. Okay. Alright, the hot air balloon continues to move. By the time the police are able to catch up to the balloon, it is located 12 miles east and 9 and square root of 3 miles south of the airport tower. Okay, so it is located 12 miles east. So 12 miles east. So let's do this. So 12 miles east. So about here. And then 9 square roots of 3s. So down south, right? So, let me erase that a little bit. So 9 square roots of 3s. So like this. Okay. Does this balloon violate the 20-mile limit? How do you know? So what am I going to use? So I need to find the r value, right? So this is 9 square roots of 3. So I can find my r value by saying, what, x squared plus y squared, and take the square root of it. So, we'll say 12 squared plus 9 square roots of 3 squared, and then take the square root of it. Okay, so that's what, square roots of 387. So that's what, 19.67 miles? So yes, it does. Okay. Alright, so to find your r value, if you don't know it, then you can take your x value, square it, and your y value, and square it, and then take the square root of it. Okay. Alright, so what angle could be used to locate the balloon's new location on the radar grid? So we know my two sides, so what's this angle creating here? Okay, so is that the tangent ratio? So all this kind of goes together again. So the tangent of theta is going to be equal to 9 square roots of 3 over 12. So theta will be inverse tangent of 9 squared roots of 3 over 12, which is going to be 52.4 degrees south of east. Okay. Okay. So polar coordinates can be changed into rectangular coordinates and vice versa. So if we take a rectangular coordinate, we have our x, right, and our y values, and this is going to be our r now. Okay, so the rectangular coordinate is defined by x and y's, and the polar coordinate is defined by r and theta, and this is my theta down here. Okay, all right. So polar coordinates give locations with a distance from the pole. So let's go back up here. I'm sorry, I should have said this. But this right here is actually the pole. So this was our radar station. So that is your pole. And it gives distance and direction from that pole. Okay. All right. Okay. So we also have, we can label negative radiuses. So if we have a negative radius, oh, my pen, I'm sorry. So this would be a negative radius. Is there just a reflection across the pole? So negative radiuses. Okay, so we label this negative r theta. Okay, all right. So our Cartesian to polar. So our Cartesian, changing from Cartesian to a polar, our conversions will be, we'll take square root of x squared plus y squared. And then theta will be inverse tangent of, and we just take the absolute value and then adjust it for the quadrant that the point lies in. Okay, so then adjust for quadrant. Okay, so for polar to Cartesian, we say our r times cosine of theta will be equal to x, and then our r times sine of theta will be equal to my y. Okay. Alright, so now take a minute and try to answer 1 through 5 for me. Pause the video and try to answer those for me. Alright, so it says plot the point on the polar grid, then rewrite each polar point in 2 different ways. Okay, so 3 pi over 3. Okay, so that's a radius of 3, so 1, 2, 3, and then it's pi over 3. Right. On the right one, 1, 2, 3, and pi over 3 is right there. So that's going to be point A. Okay. So if I want to write it in 3 different ways, I can add 2 pi to that. So that will be what, 3, and then 2 pi plus pi over 3. So that's 6, 7 pi over 3. Okay. We can write it as a negative angle, so we can subtract 2 pi. So we can say 3, and then pi over 3, that's a what, negative 5 pi over 3? If we subtract, so this was taking pi over 3 and subtracting 2 pi. This was taking pi over 3 and adding 2 pi. And then we're going to take the negative angle, or the negative radius. So if it's a negative r, okay, so if it's a negative 3, then across the reflection across the pole will be 4 pi over 3. Right, and what I do there is I took pi over 3 and added pi. Right, so for B, it's negative 6, 7 pi over 4. So, negative 6, 7 pi over 4, down here, 7 pi over 4, but it's negative 6, so it's going in the negative direction. So 1, 2, 3, 4, 5, 6. There's my edge right here. So this might be. So another way to write that is going to be 6, 3 pi over 4. Or 6, and what's that, negative 5 pi over 4? Right. If the point r, theta 1, and negative r, theta 2, have the same location on the polar grid, what can you conclude about theta 1 and theta 2? So theta 1 and theta 2 must be 180 degrees or pi radians apart. Right? Because they're across that pole. Good? Alright. So convert the point 4, 2 pi over 3 from polar to rectangular. Okay. So, 2 pi over 3. So if I'm going from polar, so my x is going to be r4 times cosine of 2 pi over 3. And my y would be 4 times sine of 2 pi over 3. So this will be 4 times a negative 1/2, which is going to be a negative 2. And this is going to be 4 times square root of 3 over 2, which is 2 square roots of 3. So it would be negative 2 square roots of 3. Okay. Alright, so 4 says convert to the point from rectangular to polar. So my r value, I'm in rectangular, the r, the radius there, I'll say 1 squared plus square roots of 3, all of that squared. This is 3 plus 1, so my radius is going to be a 2. My theta value is going to be inverse tangent of square roots of 3 over 1, which is going to be, what, 60 degrees? So this point will be 260, or we say 2 pi over 3. We usually always write it in radians, because the polar grid, you see that polar axis there, those are all in radian measures. So this is the one that we usually use here. Okay. The equation theta equals pi over 6 represents a line on the polar grid. Can you write this equation in Cartesian coordinates? Okay. So theta is going to be equal to pi over 6. So let's think about that for a second. So that is this. We'll say this is pi over 6. That was not very good. Sorry. Because that should be 30 degrees. It should be a little closer down there. The y-intercept is going to be, what, 0, 0. And the slope here, right? So the slope will be rise over what? Rise over run. Or so your slope will be what? Tangent, because rise is your y value, right? Change your x. So it'll be tangent of pi over 6, which is square roots of 3 over 3. So it'll be y equals square roots of 3 over 3 times x. Alright, let me know if you have any questions.